is over chapter 13. This tape is basically on the concept of inverse trig functions, about the inverse sine, inverse cosine, inverse tangent. Now let's look at what I want to stress in this chapter. In previous work, we've had some number, something equals to the sine of an angle. And we've been dealing with this angle in terms of degrees or radian measure. Now here's what I want to stress. Listen closely. What I'm saying is, when we write sine, this was to be an angle. The sine of an angle. The sine of an angle. The cosine, the tangent. All the trig functions were of an angle in degrees or radians. And our answer to this problem was a number, 0.5000. We usually write it as 1/2. The special angles 30, 45, 60 in those. We have fractional values that we're used to. The point being is the sine of whatever you put over here, this is an angle, either radians or degrees. And the answer that you obtain is a number. Now, this chapter is going to reverse it. We're now going to be talking about things that are written like this. Now, that is not a power. That is not the -1 power, because in this textbook he also writes the same thing like this. So I want you to understand, when you see this, it is called the inverse sine, or the arc sine. There'll be times when teacher may use both words. One time they may say inverse sine of such and such, or they may say arc sine. Textbook the same way, because some authors and some people talk this all the time and other ones use this, so you need to know that they mean the same thing. Alright, so what first thing to learn is what this symbol means. It is not a power rule. It is saying this. Let's go back up here and look at this problem. The sine of 30 degrees is equal to 1/2. Now, in Chapter 8, you had problems like this. You had the sine of the angle is equal to 1/2, and you had to find the solutions. And what you said is, what angle do I need to put in here that gives me 1/2? Well, this is what arc sine is saying. It says this. What angle of sine gives me 1/2? And the answer is 30 degrees. Now, listen to me. What I'm saying is, arc sine says that this now must be a number, and we're getting, for an answer to all of this, an angle. Now look at the difference. Let's go back up here to this one. The sine of something here, which is an angle, gives us a number. When you're dealing with arc sine or arc cosine or arc tangent, you're given the number and you're to find the angle. Now let me say another thing. This answer, all of this, is a number. The answer to it is a number. All of this, the answer to it is an angle. Keep those two things in mind. They'll be helpful as we get into some of the example problems. Alright, so I'm going to say it over and over again. Arc sine means what angle is the sine this number? What angle is the sine this number? Well, now that poses another problem. because 150 degrees also works. The sine of 150 is 1/2. What angle is the sine 1/2? Well, there's two answers, 30 degrees and 150. So what we must do then is this. For sine, we must say that if it's a positive value, it's quadrant 1. If it's a negative value, it's quadrant 4. Another way of saying that in your textbook says this: the inverse sine stays between 90 degrees and minus 90 degrees. So what I'm saying then is this. The inverse sine of 1/2 is 30 degrees. No other choice. The inverse sine of minus 1/2 is minus 30 degrees. Now, I want you to remember, I'm not saying that if you have a minus here, your answer is minus. I'm saying that the rule says that we've got to eliminate choices here. We're talking about functions, which means we must have only one answer. The inverse sine of a positive means that that angle is in quadrant 1, so that's 30 degrees. The inverse sine of a negative, now you have two choices there. That could be 210 degrees or 330 degrees. But we're going to say that we're going to just in sine talk about how many degrees this way, how many degrees this way. So if it's a positive, it's a plus 30, 45, whatever. If it's a negative, it's minus 30 degrees, 45, 60, or whatever angle it is. All right, so you need to study the first few pages in your textbook on chapter 13, because cosine, if we do the cosine inverse, let's say for 1/2, now that's 60 degrees. Or that's 300 degrees. So we have a choice. Well, again, the cosine, we're going to say quadrant 1 and 2. If it's positive, we're talking about the angle in quadrant 1. If it's negative, we're talking about the angle that's in quadrant 2. If this is negative, remember we have a choice, quadrant 2 and 3. So we're going to narrow it down, and here again, let me say, what I'm saying is this. For sine, remember, positive, quadrant 1, negative, quadrant 4. Tangent, same thing as sine. Tangent, the same thing as sine. Cosine is, if it's positive, it's the quadrant 1 angle. If it's negative, it's the quadrant 2 angle. So if this had been a minus 1/2, then 60 degrees in quadrant 2 would be 120. You have to remember your related angles and those other chapters we've been dealing with. All right, let me review then the things that I want you to understand before we just start working problems, and that's all the rest of the tape is, just examples. I want you to understand two things. Number one is the sine of this, which it must be an angle in degrees or radians, is a number. This must be degrees, and you get an answer of number. The inverse trig functions says that this is the number, and you're trying to find the angle that makes that true. What angle is the sine 1/2? And along with that, then you must memorize that what we do is take what's called the principal values. If it's positive, it's 30 degrees. If it's negative, it's a minus 30 degrees. If it's cosine, if it's positive, it's plus, 60 degrees, 30 degrees, 45. It's negative, it's quadrant 2. So it makes it 120 or 150 or 135 or something like that. Keep those things in mind as we go through, and I'll be pointing them out some more. All right, now let's go through all the examples that you have in your notes. The first one is, What angle is the sine 1/2? 30 degrees. Problem number 2, example 2. What angle is the cosine 1/2? 60 degrees. Now, if you don't know what this by now, you better go back and check out tape on chapter 2, which is talking about those special angles. But let me discuss some at the same time I'm talking about this. What angle? What angle? Well, I'll just draw an angle over here. I will draw an angle, make a right triangle. I'm going to draw an angle. What angle is the cosine, side adjacent, over the hypotenuse? Now, what I'm trying to tell you, this is an angle. There's my angle drawn. Now, what angle is that? This would be the square root of 3. Okay. Well, the side opposite the 1 is a 30 degrees, so that makes this 60 degrees. What angle is the cosine 1/2? 60 degrees. All right? This one. What angle is the tangent to square root of 3 over 3? Now, that's the same thing as 1 over the square root of 3. And again, if you don't memorize this, you don't remember what these are, then go back and draw your triangles. Draw your 30, 60 triangle and your 45-degree triangle, your 1, 1, square root of 2. This is 1, 2, square root of 3. And then you just check it out. What angle? Which one of these angles is the tangent? Tangent is the side opposite over the side adjacent. The tangent 30 degrees is the side opposite over the side adjacent. So this must be then 30 degrees. You've got to remember all those other chapter concepts. But this chapter is saying, when you read this, it says, what angle is the tangent, the square root of 3 over 3? And the answer is 30 degrees, an angle. Of course, in the back of the book, a lot of times you get answers like pi over 6. You're supposed to realize that degrees I'm writing here can be changed to radians, or you should know what they are in radians. All right, continuing. Example 4, the cosecant inverse of the cosecant's 1. What angle is the cosecant 1? Now remember, if you get these special angles like the numbers, zeros and ones, then you're probably going then either 0 degrees, 9 degrees, 180, or 270. Back to this 1, 0, 0, 1, minus 1, 0, 0, minus 1. So cosecant is r over y. Where is that 1? And that would be 90 degrees. Now, I'm not going to spend a lot of time how I come up with this 90 degrees. You're supposed to know how to do that. What I'm trying to get a point across is when you see this, two things. Number one, you read it. What angle is the cosecant 1? And number two is the answer to that is an angle. Pi over 2 or 90 degrees, whichever way you want to write it. All right, let's continue. Example 5. The inverse sine of 0. What angle is the sine 0? And that happens to be 0 degrees. And 180. You see, all these, or not all, but most of these problems you have two choices. But because of the principal value concept, the sign says the angle must be between minus 90 degrees and plus 90 degrees. Therefore, the 0 degrees is the only answer. All right, example 6. What angle is the secant 2? What angle is the secant 2? Again, if you don't already know this, you need to draw your 30, 60 triangles or your 45 triangle, and then you figure it out. Well, 30 degrees secant is r over adjacent, 2 over square root of 3. That's not it. 60 degrees is hypotenuse over adjacent, and that's it. So therefore, this is 60 degrees. Okay. Number 7, example 7. What angle is the cosine of minus the square root of 2 over 2? What angle is the cosine of the square root of 2 over 2? Looking back above here right quick, let's look at this triangle, and it would be then the 45 degrees. So looking back at example 7, this square root of 2 over 2 is the 45 degrees. Minus now, all right, cosine is negative in quadrants 2 and 3. We're not allowed to use quadrant 3, so that we must have only one answer. Therefore, it's 45 degrees in quadrant 2, so that makes our answer 135 degrees. Remembering, cosine is quadrant 1 and quadrant 2. All right, number 8. What angle is the sine of minus 1/2? Well, the 1/2 makes it 30 degrees. The negative makes it a minus 30 degrees. Because of quadrant 4. Now, I'm trying to make a point. Look at this one right above it. Number 7. If you look at number 7 and 8 at the same time, I'll point out the minus does not mean that the answer is minus. Here we had a minus, but not an answer, a minus in the answer. The minus, again, is the quadrant. Okay? Cosine, we use quadrant 1 and 2. If it's minus, we use quadrant 2. Sine, we use quadrant 1 and 4. So, and minus 30 degrees is in quadrant 4. Okay? Example 9. What angle is the tangent of minus 1? Well, what angle is the tangent 1? That's 45 degrees. Quadrant 4 makes it a minus 45 degrees. Now, this is an important concept in calculus. There are many, many problems in calculus in 2 or 3 sections there where you have to deal with and remember this concept to set up situations. All right, let's look at example 10, and then we'll look at example 11. These two are the same concept. What happens now if you have a decimal value in here? Remembering now, this is a number. This is a number. So we're saying, what angle is the cosine 0.2447? So this 0.2447 is the numbers in the middle of those tables. Now that brings me to something on using your textbook or using a calculator. There is no problem with most of these problems with calculator. You just punch 0.2447 and then you hit the inverse button and then the cosine button, and it gives you 75.8 something, some kind of decimal. It will not give you minutes and seconds. But if you go back up here and punch a minus 1 and hit the tangent button, then you get minus 45, and that works out nice. The calculator is programmed to give you the principal roots, just like that we're trying to teach here. And they have to do that so they don't have two choices. What happens if they didn't use this rule and you hit a minus 1? You have two choices, either 315 or 225. So we have to use the minus 45 degrees. All right, now let's go back to example 11. And we have, what angle is a tangent of minus 0.4770? So we find 0.4770 in the middle of the tables, and that gives us then the angle of 25 degrees and 30 minutes. The minus is quadrant 4, so the angle is a minus 25 degrees and 30 minutes. All right, I hope that helps to understand the concept of what inverse function is asking for and what it means. Let's look now at some more examples that you'll probably have in sections in calculus, and they're just kind of one step in a long problem a lot of times. But let's have this, the cosine of the arc tangent of 2/3. Now here's where you need to understand. If I have the word written, cosine, then this has to be over here an angle. We talked about that before. If we have cosine, then this has to be an angle. Well, what is the answer to inverse tangent of a number? That's an angle. Okay, so this checks. All right, now, what is this? This is an angle. This is an angle. So I'm going to draw that angle. There's that angle drawn, because it says, what angle is the tangent 2/3? Tangent is side opposite over side adjacent. I have drawn that angle. Now, I don't know what it is, and I don't have to know what it is to answer this problem. From this, I get a triangle, an angle. Well, filling that in, this would be this squared plus this squared, which would make the square root of 13. 2 squared would be 4 plus 9, 13, so it would be the square root of 13. Now there is that angle. And this is what you need to know in calculus and some places with this type of function many times. Not only what we've already been doing, but this concept. Is if you're given arc tangent or inverse sine or inverse cosine of something, that is an angle. And you can draw that angle in terms of a triangle. And we're talking about that angle right there. What angle is the tangent 2/3? Now we're asking the cosine of that angle. Remember, this is an angle. So what is the cosine of that angle? The cosine is the side adjacent over the hypotenuse. So the answer to that is 3 over the square root of 13. Now, again, let's check this out. What am I supposed to get for an answer? The cosine of an angle is a number. Okay. Always double check your work that way. Let's go back and look at example 9. Example 9 says, what angle? In other words, if I'm doing this problem, I'm supposed to get degrees for an answer. Look back now at example 12. The cosine, if I'm doing cosine, old time stuff, then I'm supposed to get a number for an answer. All right, let me give some more examples, and maybe this will help clear this up. All right, here we have the sine of the inverse cosine of something. Now remembering, this is an angle. So I'm going to go draw that angle. Well, wait a minute. I can't necessarily draw that angle like that, can I? Well, I really can. This says that the what angle is the cosine 24 over 25. That would be the side adjacent over the hypotenuse. And then this makes this 8, I believe. Okay, it'd be 625 minus 576. And that makes that 7 then, I guess. Okay. So now, from this, I have drawn my triangle. What angle is the cosine 24 over 25? The minus tells me the quadrant. So, I can answer this question right here. The sine of this angle is 7 over 25. Now, this was in quadrant 2, remembering arc cosines, minuses are in quadrant 2. What is the sine in quadrant 2? It's positive. Another way of doing this to get the same answer is realizing that this is in quadrant 2 and drawing it like this. Since this is in quadrant 2, then I'm going to draw it where x is minus 24 and r is 25, and that still makes y a positive 7. So you can do it either direction you want to. All right, let's look at example 14. Now, keep in mind, all of a sudden now I've switched. And the reason I switched, I want you to realize, what are you supposed to get for a final answer? An angle or a number? Well, this is inverse tangent of something. What is this? This is an angle, so our answer's got to be an angle. All right, now, this must be a number, final deal. Now, let's do this, going back to old part of trig. The secant of 180 degrees. What is the secant of 180 degrees? Well, that's -1. So I'll read, you should take 2 steps to do this. Just replace what's inside the parentheses. The secant of 180 is a -1. Now, what angle is the tangent of -1? What angle is the tangent of -1? Well, it's 45 degrees, and it's negative in quadrant 4, minus 45 degrees. We already worked one like that. All right. The point of this one is that you better remember what you want for a final answer. All right, let's continue then with example 15. Here we have the sine of the tangent. Now, this should be arc sine of the tangent of the arc cosine of 1. Now, why do I know that needs to be a sine? Well, let's work through this from the inside out. Let's rewrite this and then answer this. Well, if I want tangent, then this has to be an angle. That checks. This is an angle. The inverse cosine is the idea of an angle. What angle is the cosine 1? This is an angle. Tangent of an angle, I get a number. The tangent of an angle, I get a number. And inverse sine says I got to have a number. Can't have an angle. Okay. So let's continue now. What angle is the cosine 1? Okay. That's 0 degrees. Okay. Now, what is the tangent of 0 degrees? That's 0. Now, not 0 degrees here, just the number 0. What angle is the sine 0? 0 degrees. Okay, now let's continue the next one. Number 16. Now, this one and the next few are pointing out some concepts you need just to memorize and just to save you a lot of work in the next section of problems that I'm going to work on this tape. This says, what angle is the sine x? And that's the same thing as x over 1. So I draw my angle. What angle is the side opposite over the hypotenuse equal to x? What angle is the sine equal to x? All right, this angle is the side opposite over the hypotenuse. That's sine. Well, using the Pythagorean theorem, that would then be 1 squared minus x squared for this other side. This squared is equal to this squared plus this squared. Okay, so solving your x squared, y squared, r squared, or a squared plus b squared plus c squared, you get this idea for the angle. Then you ask this question. What is the sine of this angle? The sine of this angle is then side opposite over hypotenuse, and that's x. Well, that says then if you take the sine of the inverse sine, it's just whatever you have over here, doesn't it? Okay? And that's true. The sine of the inverse sine is just what you have right here. Whatever this value is, that's your answer. Just memorize that and remember it. Okay? But if you don't, then you still go through this process. This part says what angle? So you go draw the angle and set it up. Sine is side opposite over hypotenuse. And then you can work it out. Well, let's look at example 17. Let's see then if it works the other way. Is the inverse sine of the sine just whatever this is? Is that just x? Well, let's look at some examples underneath this. Let's look at example 18. And let's work this one. All right? The sine of 150 degrees. is 1/2. What is the inverse sine of 1/2? 30 degrees. So wait a minute, that's not necessarily true, is it? Okay. It's not necessarily true. But yet it is. It is and it isn't. In terms of, let's go back to this problem up here. In terms of drawing the triangle, it is equal to itself or its related angle. Okay? Let's come back to 18 and look at some other examples. Let's say this is minus 150 degrees. Then this would end up being a minus 1/2. The sine of a minus 150 degrees is in quadrant 3, and so this is a minus, and so this makes this a minus 30 degrees. Well, this poses some problems then. So you must be careful about going this other direction and saying it's just x. If this angle right here is less than 9 degrees, it's fine. It works. If this happens to be an angle greater than 9 degrees, then you're in trouble in terms of just saying it is. All right. Let's continue then and go to 19. 19 says the inverse tangent of the tangent. Okay, now we need a what? A number for an answer. Now the tangent of 4 pi over 5, that is the same thing as 4 times 180 divided by 5. Well, 180 divided by 5 is 36 times 4 is 144 degrees. Now, what is the tangent of 144 degrees? The tangent of 144 is minus something. So we're talking about the inverse tangent of a minus some number. And then we say what angle, let's just make this up, this would be 36 degrees, okay? What angle is the tangent, this minus point something? It would be 36 degrees. But it's a minus 36 because of quadrant 4. So here's a case where we start out with a positive angle and end up with a negative angle, because you must follow through. This gives us a number, and the tangent of that angle happens to be a negative number. Now this then gives us the angle, and since this tells us in quadrant 4, it's a minus 36 degrees. All right, let's go to the next example. The inverse cosine of the cosine of 240. All right, what is the cosine of 240? The cosine of 240 is a minus 1/2. So what angle is the cosine of minus 1/2? Well, the cosine 1/2 is 60 degrees. The minus is in quadrant 2, therefore the answer to this is 120 degrees. Now what I'm trying to point out by these problems is that you don't just necessarily say, since this is positive, the final answer is positive, if this is negative, the final answer is negative. You must realize that you have to carry through in 2 steps. Work this out, get that answer, and then say, okay, what angle is the cosine of that answer? And then you must remember, when you're using inverse functions, okay, and we say function, which means we must get one and only one answer, therefore we have to remember the concept of the quadrants to decide which of the 2 answers that we get. And here's another example of starting with inverse cosine on the outside and you don't get the same answer. All right, let's go to the next one then. Number 21, the tangent of the inverse cosine of x. Again, this is an unknown, therefore we draw the angle. The cosine, what angle, there's the angle, what angle is the cosine x over 1? And so it makes this 1 minus x squared. Now we ask the question, what's the tangent of that angle? There's the angle. And therefore the answer then is the square root of 1 minus x squared over x. The tangent is the side opposite over the side adjacent. These are the kind of problems that you deal with a lot of times in other math courses where you use this. So let's take another example. What angle is the tangent u? So I'll draw my angle. What angle is the tangent u? Tangent is the side opposite over the side adjacent, so it'd be u over 1. So that makes this the square root of 1 plus u squared. Now I want the question. The sine of that angle. What is the sine of this angle? The sine is the side opposite over the hypotenuse. So there's the answer. All right, continuing, let's go to the next two. They're the same concept. What angle is the cosine x over the square root of x squared plus 1? Well, I'll draw the angle. Okay. What angle is the cosine, side adjacent, over the hypotenuse? And that makes this a 1. Going through, you ought to be able to handle your a squared, b squared, c squared bit. Now, we're asking the sine of that angle is what? The sine of that angle is the side opposite over the hypotenuse. All right, the next one. What angle is the cosine, the square root of x squared minus 9 over x? We draw the angle. What angle, there's the angle, is the cosine, which is adjacent, over the hypotenuse? Okay, and that makes that 3. Okay. Now we ask the question. The tangent of that angle. The tangent of that angle is the side opposite over the side adjacent. Okay. All right, let's look now at the rest of their examples. All right, let's look at example 25. We have the sine of the parentheses, the inverse cosine plus the inverse sine. Now, you cannot remove parentheses and just multiply this times that, remembering that this is an angle. This is all an angle connected to that. Now, the point of this is this. The inverse cosine of this is an angle. That's one angle. We'll call that angle A. The inverse sine of V is an angle. That's why I made such a long time of stressing at the beginning of this tape, that this is an angle. So what we really have is the sine of an angle plus an angle. And the way you work the sine of A plus or minus B is back to chapter 7, the sum and difference formulas. So it's the sine, cosine, sine, cosine. So it's the sine of the first angle, there it is in parentheses, the sine of the first angle, that's A, cosine of the second angle, that's B, plus sine of the second angle, that's B, cosine of the first angle. And that's how you work all the other problems in your textbook that have the dealing of sine or cosine or tangent of inverse plus an inverse, or pi over 3 plus an inverse. Just keep in mind that this is an angle, and you'll see the formula work out that way. All right, finishing the problem. This now goes back to the problem we just got through working. Makes an individual problem. What is the sine of the inverse cosine? All right, what angle is the cosine u? I draw the triangle. Here's my angle. What angle is the cosine u? Side adjacent over the hypotenuse. That makes this 1 minus u squared. So what is the sine of this angle? The sine of this angle is the side opposite over that. So the answer to this problem is the square root of 1 minus u squared over 1. All right, then we work this one. What angle is the sine V? Well, we'll go draw our triangle. This angle is the sine V. Okay, side opposite over the hypotenuse. So that makes this the square root of 1 minus v squared. Now our question is, what is the cosine of this angle? The cosine is the side adjacent over the hypotenuse, which makes that the square root of 1 minus v squared. So we have this times this, plus the sine of the inverse sine is v. The cosine of the inverse cosine is u. So that comes down to that, and that comes down to that, and leave your answer like this unless the teacher wants it simplified. The concept, though, two things, looking at all the problem at one time, is whenever you have that kind of problem, you must realize that's an angle and that's an angle. And then you're going to be using the half angle, well, the half angle formula can be on one or two of your homework problems, the sum and differences, the double angle formulas. Those 10 formulas are identities that you had in Chapter 7. All right, let's look at example 26. Here we have the sine of 2 times the inverse sine of x. Now what I'm trying to point out here is that this is an angle. So what we have is a sine of the double angle formula, the sine of 2 theta. So that's 2 sine of the angle, cosine of the angle. All right, then we work it. 2 times, right? Sine of the inverse sine is just x, just whatever this is. Now cosine of inverse sine says we've got to draw a triangle. So we draw our angle. What angle is a sine x? So that would be the side opposite over hypotenuse, and that makes that the square root of 1 minus x squared. So now what's the cosine? The cosine is the side adjacent over the hypotenuse, so that's 1 minus x squared. And therefore that's the answer. Again, trying to point out that this is an angle. And if you have 2 times one of those, then you're talking about a double angle. All right. Let's go to example 27. Now, 27 has the arctangent of 8 minus the arctangent of 3 equals arctangent of 1/5. Prove that this is true. Prove this minus this is equal to this. Well, the way we work problems like this, then, is to take the tangent of both sides, or the sine of both sides, or the cosine of both sides. Now, which one to use? Well, the method I use is if I take the single one over here, forget about what I have here, and I take whatever I have over here. If this is tangent, I will take the tangent of both sides, because the tangent of the inverse tangent is just the number. I won't have to draw a triangle and have to work it out. So that's the indicator. All right, so let's take the tangent of both sides. Taking the tangent of this side is equal to the tangent of this side. Now this is the tangent of angle A minus angle B. So, using the formula, identity, the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of B equals to, well, what's the tangent of the inverse tangent? It's just the number. All right, then working this out. This one comes out very nicely because it's the tangent of the inverse tangent of 8, that's 8. The tangent of the inverse tangent of 3, that's 3. 1 plus the tangent of the inverse tangent is 8. Tangent of the inverse tangent is 3. And therefore you get on top 8 minus 3, that's 5, and down on the bottom you have your 24 plus 1 is 25, and that does reduce to 1/5. The point being is that you take the tangent or sine or cosine of both sides. Let's look at example 28, the last example on this tape. Here we have cosines, but that's not important. Some of your homework problems you'll have sine or sine and cosine. This is the indicator here. What you need to do then is take the cosine of both sides, so that you'll have the cosine of the inverse cosine of 33/65. All right, so I take the cosine of both sides. The cosine of this side would be the inverse cosine of 12/13. All right, this is the cosine of A plus B. So that's cosine cosine. I'm not calling those out. That's just cosine of A, cosine of B, minus sine. Sine. Equals, well, the cosine of the inverse cosine is just the number. Well, let's see if this is true. Coming back over here, the cosine of the inverse cosine is just the number. The cosine of the inverse cosine is just the number. So we get that, minus, all right, multiplying that, that's 48/65. Now over here, the sine of the inverse cosine. Uh-oh, that's going to require a triangle. So let's go down here, looking at the triangle. I will draw my angle. The cosine is 4/5. That makes this 3. Now, what is the sine of this angle? What is the sine of this angle? Sine of this angle is the side opposite over the hypotenuse, so this becomes 3/5. All right. Now let's do this one. The sine of the inverse cosine is 12/13. Again, we will draw our angle again. The inverse cosine is 12/13. In this angle, what angle is the cosine 12/13? And working this out, this will be 5. 169 minus 144. Now we ask the question, the sine. The sine of this angle is the side opposite over, and multiplying this together, we get 15/65. And subtracting that, it is equal to 33/65. This then concludes the tape on Chapter 13, Inverse Trig Functions.